Okay, talking about the second midterm exam, just the next Monday, which is 18 or 19 it will be. It will be 19. It's simple. This exam will be shorter than material. The material for this exam shorter than the previous one. I think I will put, it is also 15 questions. I don't know yet if I put them 17 with 2 extra questions. The grades in the grade book, you can see them, your grade may be 16, 14, out of 17, right? It is okay. At the end, I will change this, it will be 15. So your grade will be, this one will be 15 out of 15. This one will be 14 out of 15. Okay. The material for the second exam, it is just 2 chapters. It is the work and kinetic energy. And the second chapter, which is the potential energy. Potential energy, we have many kinds. We have gravitational potential energy. We will not study all the chapter we have. There are many materials. I will not just what you see in the lecture, you are required to study on them. You have the elastic potential energy, and we see what is the elastic potential energy. Also, we will see the work done by the friction force. By doing the examples in this chapter, we will apply the work and kinetic energy in these examples. We have today and the next lecture, we have many examples, all of them on the same material. Your exam on them. Any questions? In general, it is simple. You need just to solve examples, just what we do now in the lecture. Okay. We need to remember now that the work will be, it is an energy, it is a converted energy, it is an exchange energy between 2 kinds of energy. The work may change to be a change in kinetic energy, a positive change. Means that kinetic energy 2 minus kinetic energy initially. And the work is also equal to minus the change in potential energy. That means U1 minus U2. This potential energy, maybe it is gravitational, which is mgh. Maybe it is elastic, which is 1k x squared. Maybe it is a heat. Heat lost in the environment because of the friction force. We will see that now in the next example. And the total energy in general. We have the total mechanical energy as we computed it in that slide in the previous lecture. The mechanical energy is equal to kinetic energy plus potential energy plus another potential energy, maybe plus another potential energy. In the future, any energies in our system, all of them are equal to the mechanical energy, which is constant. It's constant always, even with the work done by other forces. Other forces, these energies done by conservative forces. the work done by other sources like friction force, it is waste of energy in our system. Okay, let us now look at this example. Any questions about the material? And the formula sheet will be shorter than the previous one. Maybe you will see a question ask you about the acceleration, ask you about mu k. Now we have a question about mu k and the acceleration and velocity, which is from the previous material, but we know about it. Okay. Now we have this example. Example one, we have a spring with no friction. We have gravitational plus spring, which is elastic. Also, we have no resistance, no friction force. Okay, now we have this. We have this object. Any questions online? Okay. We have this mass. We have a spring here. This spring constant is K, small k. We have 4 positions. This is the first one. This is the second one here. The third one is just before reaching the spring. And the third one, the fourth one, I'm sorry, it is when the spring gets compressed. And the object, because it has a kinetic energy, it can push that spring. And we have X compression distance, or you can name it delta X. It's okay. Even X or delta X. This is X or delta X. Now, we have the mass, it's 5 kilograms. We have K, which is 120 newtons per each meter. Yes. We have, this is Y1 equal to 3 meters. And that's it. We need to compute everything. Is our system clear? Okay. We need to compute at point number 1. We need to compute the potential energy. Okay, at point number 1. At point number 1, we have the mass at altitude 3 meters from the ground surface. Also, the spring compression is 0. Let me now put the formulas. U due gravity is equal to M G Y or H. U elastic forces is equal to half K X squared. Kinetic energy is equal to half M V squared at each point. And mechanical energy is equal to kinetic energy plus any other potential energies. Now, potential energy at the first point. What's the kind of this potential energy? Is it gravitational or elastic? Huh? This, yes, this is gravitational energy, which is M G Y1, which is equal. The mass is 5, G is 9.8, Y is 3. This will be equal to 147 joules. 147 joules. Before go to the next, I don't know what is the next requirement. How much the kinetic energy at point number 1? Is it? Yes, it is the second requirement. How much the kinetic energy at point number 1? It is a free fall. How much the velocity here? V1 is equal to 0. The kinetic energy it is a half M V1 squared. But V1 is 0. Then this will be equal to 0 joules. Yes, the third one. The mechanical energy at the first point, it is equal to the kinetic energy at first point plus the potential energy at that point, which is a gravitational one. This will be equal to 147 plus 0, which is 147 joules. This mechanical energy will be constant in all our system. It will be equal to M2, which is equal to M3, also M4. Is that clear? We don't have any friction force. So this mechanical energy will stay constant. 4. I need the potential energy at the 0 level. I need potential energy at point number 2. I think some of you know that it is equal to the potential energy at point number 3 and at point, that's enough. The potential energy at point number 2 and number 3, how much is it? It is M G multiplied by Y at that point. M G Y2. Okay? How much Y2 now? Y here at this level is equal to 0. So this will be equal to M5 G 9.8 multiplied by 0. This will be equal to 0 joules. Now, this is the gravitational potential energy. It is equal to 0 because the altitude is 0. The potential energy to for this object here, it depends on this altitude. But the potential energy here, if our 0 level is here, this potential energy is 0. Outside, we have -3 meters almost to reach the street level, for example, or the ground level. If we need to put the potential energy there, I will show you now. The potential energy computations depends on where is your zero level. Our zero level is here. So our gravitational potential energy is equal to 0 at point number 2 and at point number 3. Also at point number 4, the gravitational potential energy is also 0. So also potential energy due gravity at point number 4 is equal to 5 multiplied by G, which is 9.8 multiplied by 0, which is equal to 0 joules. But we have at point number 4, we have another kind, another shape of potential energy, which is elastic. Okay, all the energy with the object is paid to compress that spring. Okay, now I need number 5, the kinetic energy. 5, I need kinetic energy at point number 2. This is equal to half mv2 squared, but I don't know the velocity at point number 2, right? But I know another law now, another formula. The mechanical energy 1 is equal to mechanical energy 2, which is equal also to mechanical energy 3, which is equal to anytime kinetic energy plus the potential energy. At this point, we have kinetic energy 2, we have potential energy due gravity. At point number 2, also we have potential energy due elastic at point number 2. This is potential energy due elastic forces. This is due gravity. At point number 2, 2, 2. We are talking about 2. How much the mechanical energy? It is 147 joules, right? Elastic energy, we don't have any compression for this spring. So the elastic is 0. The potential energy due gravity, we computed, it is 0. Then all the mechanical energy now is a kinetic energy. So kinetic energy at point number 2 is equal to 147 joules. Any questions about that? Also, we have the same situation at point number 3. At 3, also mechanical energy at 3 is equal to 147, which is equal to also to the kinetic energy at point number 3. Because the potential energy for 2 kinds are zeros. We are at point number 3 now. We will go to number 4. Oh, now, another thing, we can compute the velocity. This one. We have the general, we have kinetic energy equal to half mv squared multiplied by 2, both sides. Then we have 2 here and 2 here. This will cancel with this. Divide over m, divide over m, divide over. This will cancel with this. So we have v squared is equal to 2k over m. Then v is equal to 2k over m under the square root. Now, at point number 2, v2 is equal to under the square root 2 multiplied by k2 over m, which is equal because k2 is the same as k3. This is 2 equal to 2. and the mass is the same, which is 5. So the velocity, because we don't have any friction force, the velocity at point number 2 and at point number 3 are the same. V2 and V3. It's the same. Any questions about that? Okay. Now V2 equal to V3. We don't have any waste. 2 kinetic energy 147 over 5. It will be equal to how much the velocity is 7.67 meters per second. This is the velocity here and here. Any question about that? You can imagine that we have 3 boxes, 3 or 4. Mechanical energy in a box is equal to a kinetic energy plus a potential energy. Just we need to add and subtract energies from part to part. Okay. Let us go now to point number 4. By the way, if you need anything to ask, please visit the office hours. And also, I am, in general, I am in my office. 100, no, not one, IS 102. Just down floor. You can ask about anything. Okay, now point number 6. We need the kinetic energy at point number 4. We don't have a spring here, but when this mass push this spring, it reaches the last point or the end point here, and then it spends all of its energy. Its energy is a kinetic energy here. Its kinetic energy is 147. This mass paid all of these joules to compress the spring. Then there is no more energy with it. How much velocity then? There's no velocity. Okay. Then the velocity here, V4, is equal to 0. Is this point understood? This is the way to solve any physics problem. You need to stop at each stage to understand what you need to do. Now we need to compute kinetic energy at the point number 4, which is equal to half. M, it is 5. Velocity is 0 squared, which is 0 joules. How much the potential energy due gravity at point number 4? Who can tell me? How much the level altitude? It is mg1. How much y? Y is 0. The potential energy due gravity is 0 joules. Okay, our system has or contain, we can say that 147 joules. The kinetic energy is 0. The potential energy due gravity is 0. Where is my money? Where's my joules? Where's my energy? Yes, the energy is stored now. The joules are stored inside that spring. Okay. In other words, this energy, which is the potential energy, sometimes we can call it the hidden energy, the internal energy, or something like that. It is stored here. If we let that spring move, then it will move and it will give us our energy again. We store our energy there. It is like just like the battery for electricity. Okay? Now, where is our energy? The mechanical energy at point number 4, it is equal to our energy always, which is 147 joules. It is equal to the kinetic energy at point number 4 plus the potential energy due gravity at point number 4 plus the potential energy due elastic forces at point number 4. This is 0 and this is 0. So all of my mechanical energy are elastic energy now. What can I compute? Now, in the previous part, I compute the velocity. Now I can compute the x, the compression displacement or distance. Now, the potential energy, elastic potential energy at point number 4 is equal to half k x squared or delta x squared. It's okay, which is equal to 147 joules. K is given. We need to compute x. Multiply by 2. This is 2. This will go. Divided over k. This is over k. This is over k. This will cancel this. We have x squared is equal to this. Take the square root. We will remove that. K is 12. This will be equal to x is equal to almost half a meter, I think. It is 0.495 meters, just like this. If we assume G equal to 10, then it will be 0.5. This is because the approximation that G equal to 9.8, because we don't approximate. Okay. Any questions so far?
Yeah, I have a question.
Yes, please.
So on the paper it said that it was 147 over 60.
What? Which page? Just 3 or 4?
Page 4. And
What?
then, so when the x be equal to like 4.95,
Yes, this is x squared. X squared is equal to over. This is 120. I'm sorry, not 12. Over 60. Because this is 2. Cancel with this. It will be 60. Okay. Remove that square root. This is x squared. I'm computing here x squared. So x squared is equal to 24.5 meters squared. I don't need x squared. I need x.
yeah. So would it be 4.95? No.
Yes, 4. It was computed. When I prepare this, I change the numbers, but I don't change this one. I think over 60. Aha. It is not 24, it is 2. It is not 24.5, it is 2.45. Then we have this, just we need to change the decimal point. This is x squared. X squared not equal to 24.5 meters squared. It is equal to 2.45 meters squared. Thank you for this note. Just a tell. Any question about everything? We have energy. This energy, it is a potential energy initially. We don't have any kinetic energy. you don't have any elastic potential energy, this mass start to convert its energy from shape to shape by doing a work. During this path, we have a work. Okay, this one it is F multiplied by the displacement, as we know, but I don't think you to include it. Now the energy converted to from potential gravitational potential energy to kinetic energy. Then the kinetic energy converted to a potential energy in elastic system. Okay, that's it. We will see now another example with another energy forms. Online, I'll see that. Where is 12 from? Wouldn't be for. Yes, I answer this. It is not 12, it is 120. This is K. It is not 12, it's 120. Yes, right. And I answer the second part, which is the X will be 0.498, right? There's a mistake here. Thank you. Now another example. They have the same notes. We have almost the same shape. Have a mass. Is equal to 10 kilograms. This is just numbers, but the technique, the solution is the same. We have point number 1. Point number 2. Also, we have point number 3. Now we need to spend our energy. We have a friction force now at this path. So we have the mass starting at this point, ends and stop at this point. This is point 4. The displacement, that mass moving, it is 10 meters. Then its velocity here, which is B4, is equal to 0 meter per second. Y1 here. Y1 is equal to 6 meters. I'm asking about find mu K, not mu S. Mu S for static friction force. Mu K for kinetic friction force. We have this mass moving here, and there is a friction force. Another question: how compute the heat or maybe some energy produced by this system? Who can tell me about this point? Who can explain it to me? If we have a friction force Listen, you can hear now the sound for the eraser with the surface. If there is no friction force, then you will not hear any sound. Because of the friction force, then we have sound. The sound is the motion or the vibration of the air particles. It is energy. So its energy, it's wasted and spent during this motion, which is with friction force. If we can measure the change in temperature for the two surfaces, this one and this one, we will find them gets hotter or warmer, okay? And the environment around them, the air here. So, because of the friction, we have another shapes of energies, which is the sound, which is the mechanical waves energy. Also, we have heat energy, which is another kind of potential energy. How can we find them? We will see that by computing the friction. It's simple. We have the same kinds of energies. We don't have now the elastic potential energy. We have the work relation. Which is Fx cosine theta between x and f, or f and x. Okay? We know this relation. Any question about it? Now, what are the requirements? How can we find mu k? As we know, friction force is equal to mu multiplied by the normal force. If the friction force is static, then this is mu s. If the friction force is kinetic, then this is kinetic, and we need it. Okay? The normal force, we have the object here has its weight downward and the normal force upward. And the object is not flying and isn't diving inside the surface. So the two forces are the same, are equal. Okay? Because there is no motion or there is no acceleration in vertical direction. So the normal force is equal to mg. mg downward, but the normal force upward. Okay? M is given, G is given. We can compute M. So this is equal to the mu k, which is unknown. M, it is 10. G, 9.8. So we now have two unknown parameters, which are Fk and mu k. We know this. We need to find them. We need to find Fk to find this one. How can we find Fk? Let us see what we can do. The mechanical energy is equal to kinetic energy, always, plus the potential energy. Our potential energy here is gravitation. Okay? Gravitational potential energy. Plus any other kind of energy we don't, it is new about for us, which is the potential energy due the friction force. It is not potential energy. We can't tell it is a work by other forces, which is the friction force. Now, the mechanical energy, maybe it is a kinetic energy or potential energy or work done by the friction force. It is just like money. Now, at point number 1, the velocity is 0. So the kinetic energy is zero. Now the mechanical energy at point number 1, this will be equal to half m v1 squared plus mg y1 plus the work done by the friction force, which is now we don't have any motion, we don't have any friction force. This is zero. The velocity is zero. So the mechanical energy is equal to the kinetic energy, the potential energy, which is 10 multiplied by 9.8 multiplied by 1, which is 6. This will be equal to 588 joules. This is the total energy in our system. We start our system, our motion with this energy. So our system is rich in energy by this amount. If we need to compute another requirement, which is the kinetic energy, now M2 is equal, this is point number 2. We need to compute the kinetic energy here and kinetic energy here. It is the same like the previous example. M2 is equal to 588 joules, which is equal to kinetic energy 2 plus potential energy 2 plus your gravity plus the work done by friction force at this stage. There is no friction force now, zero. The potential energy here, how much Y? How much the altitude here? How much Y? So the potential energy now, at this point, because this 6 meters are from here, Y is 0. Mg Y. Mg Y. Y 0, that's the potential energy. Q gravity now is also equal to 0. The kinetic energy at point number 2 is equal to 588 joules, which is equal also to kinetic energy at point number 3 also, because we don't have any friction force here, and there is no changes on the potential energy. It's the same. Now all of our energy is kinetic energy at point number 2 and point number 3. We can compute the velocity. V is equal to 2k over m. Right? You can. Now, at point number 4, look, at point number 3 here, we don't have any friction force. We have smooth rotation, kinetic energy, that's it. Now, our object starts slowing down like this. Okay? Where is its energy? Its energy is spent in this surface. So, at point number 4, I don't know. Now, my mechanical energy is 588 joules is equal to my mechanical energy at point number 4. Again, which is equal to kinetic energy at point number 4 plus potential energy at point number 4, which is gravitational, plus the work done by the friction force. How much the kinetic energy here? Look, this is point number 4 there. The velocity is 0. The kinetic energy is 0. The potential energy is 0. Then all of my joules are spent in this wall. So work U friction force is equal to 588 joules. By the way, it is a negative work because both of these things before here, we have the total energy here, we have it 588. Then we have it 0. The total energy now zero. So the kinetic the work done by the friction force is negative because when we add it to this part, it will be zero. But we need to compute the magnitude of that work. But we know that the work in general has a formula. We can use this formula even if our force is a friction. Now we can use it. It is equal to friction force as a force multiplied by x, which is the displacement, which is given, multiplied by cosine theta between the force and x. The friction force, the motion is to the positive x-axis. The friction force is to the negative x-axis. This is the friction force. X direction is to the positive x direction, right? Because the motion to that direction. This is x. How much theta between them? How much cosine theta? It is minus 1. Any questions about this? Please. Okay, then cosine theta is cosine 180, which is minus 1. Because of that, I told you that the work of the friction force is negative. Now, this is equal to the friction force multiplied by x, which is 10, multiplied by minus 1. All of them are equal to 588. I will put them here. So 588 is equal to the friction force multiplied by 10, multiplied by cosine 180, divide over 10 or minus 10, divide over minus 10, this will cancel. Then the friction force is equal to negative 580.8. What is the unit? Newton. Right? The friction force is direction to the negative x direction. Now, what we need to do to find the mu k, F, this is kinetic because the object is moving. Mu k multiplied by mg, which is the weight, which is equal in magnitude to the normal force. So this is 58.8 is equal to mu k, m is 10 multiplied by g. Now divide over 10 multiplied by g. Both sides. Can you see it? This cancels this. So mu will be equal to 1 point how much?
I think you did it backwards on the sheet.
Tell me again, please.
I think it's 1 over 1.67 because you did it backwards on the sheet. You put 10.9. You put 98 over 50.
Yes, because 10 multiplied by 9.8 is 98. I divide over 98, right?
You meant you did it the opposite. You put UK equals mg over the force of friction.
Right. Wait. On the opposite. Okay, I'm sorry for that. I finished this at maybe at 1 at morning. We need to take this is 1 over mu. 1 over mu k is equal to mg over f, ومنها mu k is equal to 0.9 5, almost 6. This is a mu to minus 1. Previously, I have been allowed to find the errors when I record the YouTube videos. Now I don't record them, so the errors are the same. Yes, please.
What's the negative sign?
Yes, I take the magnitude. We have the minus sign for the force. The friction force has a negative sign here. I take the magnitude. Take just the magnitude.
So it's always positive.
Excuse me?
It's always positive when you're calculating.
Yes, when we need to compute the mu k, it is positive. Yes. The minus sign, to be more clear, it tells about the direction. When we take or when we know this information, bit of information about the negative sign, then it is okay. We can remove it and use the magnitude that was. Okay? Thank you for telling me. Any questions so far? I talked about the negative sign, just tell about the direction. Yes. Okay, now what if I need you to compute? I need you now to compute the potential energy, the potential heat energy, or sound energy, or maybe both of them, because we have heat and sound for this system. We can compute them now. Who can tell me how? If you remember the books, our subsystem in the first lecture about the energies, when I told you about that we have total mechanical energy. Now our mechanical energy is 588 joules. We have kinetic energy. We have potential energy due gravity. We don't have any potential energy due elastic forces. We don't have this power. Okay. We have potential energy for heat or sound. This potential, this energy, this mechanical energy, joules, there was here. Okay, then they become as a kinetic energy. But when they move from here to here to here, there's a water moving them. Now we have a kinetic energy transferred to heat or sound energy by this way. What is the kind of this work? What is this work? What is the work that converts these joules to heat and sound energy? It is the work done by whom? By the friction force, right? So the work done by friction force convert these joules to a heat and sound energy. So now our heat and sound energy are all our mechanical energy. all of the 588 joules, there were potential, then kinetic. Now there, we don't have nor potential nor kinetic, neither potential neither kinetic. But we have a stationary object with heat and some sound. So all the energy converted to heat and sound. We cannot call it internal energy now. But if our system is the room and it is closed, nobody outside can hear the sound, then we can assume, anyone outside can assume the heat and the sound as internal energy for our system. It is internal now. But it is not internal for this small system. Okay? But for the spring, when we push the spring, it is internal energy between the particles of that spring. Now we will see another kind of internal energy as heat, maybe. Is this understood? Any question about it? When me or any other body ask you about the heat energy, it is just the work spent by the friction force. Any questions online? Bye. We have now another example. As you see now, we apply the kinetic energy, the work, the potential energy, your gravity, your spring force, the work done by friction force. All of these things, which are just in one example or two examples, this is our material for the second example. Now we have this system. This is the zero level. We have a spring. Our spring here is the elevator system. There is a security spring under the elevator room, because when the rope gets cut or something like that, when it gets down, it will not hit the ground directly. There's a spring just to consume the high velocity, the kinetic energy. Its potential here, that energy here, we have mechanical energy, okay? We have potential energy here, due gravity. At this point, we have kinetic energy. At this point, if the kinetic energy, all of it, go in that collision, then it will hurt everything, okay? Because of that, they put a spring to convert this energy slowly to a potential energy in elastic source. The collisions, if we have a collision like this, it will hurt. But if our collision is like this, we have a sponge, the collagen will be uh, not harming, or I don't know the right way. Because of that, they put this spring to make the exchange of energy takes more time. Okay. Then our energy, we have kinetic energy is equal to 0. We have potential energy, due gravity is equal to 0. We just have potential energy to elastic forces. Okay. Now, after that, as we expect, the spring will release the mass with another velocity, but this velocity is less. This is V3, this is V1. You need to know that V3 is less than V1, right? Because most of, if V3 equal to V1, then the mass will reach the highest point again. Now, in our example, if we have mechanical energy is equal to 25,000 joules, they are now here potential energy. The kinetic energy here is equal to 0. Also, the potential energy due to elastic potential is equal to 0. Here, when the object reaches this point, its energy is the same. Now, how much the energy here? It is the same. The kinetic energy is 0. The potential gravitational energy is 0. All of this energy is stored in the spring now. But in the third stage, it is given that kinetic energy at third point is equal to 24,000 joules. The gravitational potential energy due gravity at point number 3 is equal to 0 now. We are at the same level. The spring, due to elastic, potential due to elastic is equal to 0 also. Because the spring now, it is no more compressed. It is compressed just here. But the kinetic energy is less than the total mechanical energy. How much the waste of our energy now? We have 25, then we have 24. We need 1 more 1,000 joules. Where are they? Where? Heat where? Yes, tell me. The spring? This spring, maybe it is just like this thick. And like this altitude or something like that. When we move, any object is start moving. It will start generate heat. Okay. The spring not rotating about itself, but it is just like this. Its internal particles move with respect to other. There are friction, internal friction force. Yes. Then there is an internal heat in this spring. So these 100 joules are spent as a heat inside that spring material. This is internal force stored there. We don't need it. It is waste, not waste. We don't. But all of our energy as a mechanical physics, okay, we need to compute all the energy. We can't compute. It is just we know that we have 25,000, and now we have 24,000. Where is that risk? They are internal energy as heat in the spring. Any questions? Any question about exam? Yes.
Will you be giving us a review like last time? Will you be uploading a review
Review, yes. Look, we have today 3 examples as a review. I think we have in the previous lectures, we have also examples. In the next lectures, the lecture, on Wednesday, yes, I think, we have also more examples. All of them, you can take them as a review. If I have any new thing, new idea in my mind, then I will upload it to you. Okay? In general, in the class, online, anyone need any help, please ask me. Tell me and I will prepare a Zoom meeting in an hour, half an hour, anytime. It is your time, you don't need to waste it. You don't need any friction force in your time to be lost. So please, anytime, ask to finish. In general, your grades are good, and I tell that I can help. And your total score in the course, it is not in the first or the second exam or the third. It is all over the world. It is a comprehensive score. Okay. So don't worry about any low score. But tell me you can do and earn more scores. Any questions online? Okay. Thank you.